Welcome. In this lecture, we go through something to kind of look out for, which is that this existential quantifier, or their exist statements can be kind of disguised within a sentence or a statement. Okay, so some definitions, for example. So some definitions. For example, involve sometimes disguised existential quantifiers. Okay, so here's an example. So definition, so example, definition. Okay, so an even number is an integer of the form, so an integer of the form n equals 2k for some k in the integers. Okay, so the question is, like, where does, there is an existential quantifier in here, and where is it hidden? And so one thing that might kind of help is to say, so this could be written, like this could be written as, let's just use another color, so this could be written, right, the part where I say, of the form n equals 2k for some k in z. Okay, so this instead, this part here, could be written, there exists an integer k such that n equals 2k. Okay, so this is actually kind of hidden in here. So then looking at this, how would we prove? So to prove that this, so that n is, I want to get sure, make sure that this is the same. So n, so an integer n is even. I was checking whether I already was assuming it was an integer, but of course it was. And then, so how would we do this? You need to find the k, so 1. Need to find in your scratch work. And then state in your proof, right, the k, and then you need to, so you need to show that the first thing that you're going to need to show is that k is actually an integer, right, because I said there exists an integer k satisfying this. So we need this, and you also would need to show that n equals 2k. So that would kind of be the work in showing that this actually works. Okay. So when you would see kind of example, and this is not an unusual thing, actually. There's quite a few times you might want to show that something is even, or there exists an even number, or something like this. So this is a definition it's good to get used to working with, and it has within it an existence statement. So you kind of need to know what it means to work with an existence statement like this, and how do you do it? So to show that this integer is even, then you need to find in your scratch work and state in your proof the k. And then you need to show, like, so say, like, let k equals 3, then k is an integer, and n equals 2 times 3. So I'm good, okay? And that's how you would show that. And maybe actually, I didn't yet write this, but maybe we should include in here that if you know that n is an integer, is an even integer, right? Then this actually gives you something, which you can, is that you know and can use that there exists a k such that n equals 2k. And you don't even necessarily know what that k is, but a lot of times you don't need to. So a lot of times in proofs that involve the even numbers, for example, the very first thing that you want to do is to say, let k be such that n equals 2k. Like, to rewrite your n in the form that, like, the fact that it's even gives you something to work with. You have this way of writing it. So often being able to rewrite things in a form like that is very useful. Okay? So, look out for kind of the language where these things can be hidden, because, when you're proving things and you need to show that something exists, you have this way of doing it. You state what the example is, and then you show that it satisfies the conditions it's supposed to, but then it can also give you a tool to work with, like a new way to write your integer n or something like that. Okay, so I hope that made some sense and was helpful, and I will see you in the next lecture.